you have your chapter 3, that is pair of linear equations in two variables. Okay, so now first of all we need to learn what you are going to learn in this chapter. This chapter you are going to learn about pair of linear equations. What are linear equations? That can have a maximum degree of 1, and pair of them, that means that there should be two equations equal to signs, two of them should be there. Then you have two variables, not only x, you also have some y. Okay, you also have some y, and there may be some constant or something depending on the equation. So first of all we need to learn the general form of the pair of linear equations in two variables. The general form. The general form of pair of linear equations in two variables is a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. Okay, for generally, if you consider a linear equation, not a pair, if I am considering a linear equation in two variables, what does it land up to be? It comes to be ax plus by plus c is equal to 0. First we will deal with this and then later on go to this. Okay, so I'll tell about this again once more. So now you have the linear equations in a linear equation in two variable. There should be some condition. It cannot be like simply I can go on putting any number for a, b, c and all. So just you can, by seeing, you can tell that a and b both not 0. Both not 0. That means that the case should not be like a is equal to 0 and b is equal to 0 both together. They can be 0 at one case and b can be 0 at some other case when a is not equal to 0. Okay, so both a and b cannot be equal to 0. Why this is because, so if you multiply 0x and 0y and you have one c that is equal to 0, and how can c be equal to 0? How can c be equal to 0 every time? Maybe c is some other number. So we need to just take care that a and b, both of them cannot be equal to 0. Okay, so even though this is all about algebra, we always learn about the geometrical representation. Even in the previous chapter we learned about the geometrical representation of that graph and polynomials and such things. So here you are going to learn about the geometrical representation. So what it is going to be? So this is linear equation. The word says line. Since it was a linear polynomial, in that case we got a line. Always it was a line. So this is the linear equation that shows that it is going to be a line. So it is a line. So maybe I'll draw a rough graph of something. This is one of the lines that has ax plus by plus c is equal to 0. This is the general form of that equation. So how it is going to be, and how do you find the solution? The main thing of this chapter is you are asked to find the value of x and y. So you are more concentrating on the solutions of this given equation. So first of all we need to learn, for a line, for a given thing, that is for a given linear equation, how do you find out the solution? Now we have found out the geometrical representation. For the geometrical representation, you can see that there will be so many points on this line. There will be so many points on this line that is belonging to that given line. So what are those points going to be? So let me consider the points to be x comma y. Say a general point that is x comma y that is on this line, that is present on this line, is a solution for the equation. If it is belonging to line representing it. Okay, so if x comma y is a point of the line that is representing the given linear equation that is in x and y, then x comma y, that is the point on it, is a solution for the equation. Okay, or I can tell in the other way also. I can tell that if x comma y is a solution for the given equation, then it should be belonging to this line. Okay, that is a vice versa statement. That is not so much useful. Only this much you need to understand. That is, if it is on this line, then it is a solution for the given equation. How do you find algebraically the values of x and y? So just give some random value of x, put x as 1, 0 or anything, get the value of y just by substituting the value at x. So you are going to get the value of y, and you're going to get a set of points from which you are going to plot the graph of that line. Okay. Next thing is what you are going to learn is substituting the value of x and y. So let me take a number. So maybe a pair of not a pair, only one linear equation in two variables. So it comes to be, maybe I'll take this one, that is x plus y minus 5. So I'll substitute two things, 2, 3 and 1, 7. From this I can find out whether they are going to be the solutions of the given equation, linear equation. So for that I need to substitute this in place of x and 3 in place of y. Okay, so the left hand side becomes 2 plus 3 minus 5. 2 plus 3 is 5, 5 minus 5, 0. Right hand side is 0, therefore it is equal to 0. This is a solution. Okay, now we have 1, 7. So again substitution, 1 plus 7 minus 5. 1 plus 7 is 6. 6 minus 5 is equal to 1 and not equal to 0. Therefore, it is not going to be the solution of the given linear equation in two variables. So that is easy way to just go on substituting the value of x and y to find out whether it is going to be the solution of the given linear equation. So now we have a pair of lines, pair of linear equations in two variables. So linear equation in two variable comes to be one line. So pair of lines refers to the pair of linear equations in two variables. Okay, here what you are going to have, the lines can be of three types. The lines can be either intersecting. Intersecting means they are just going to have only one common point, and that point is the solution of the given pair of linear equations in two variables. Here you have parallel lines. Parallel lines are like this. They are not going to intersect in any point. They are running very parallel. That means that they are not going to have any solution. That will be in the later part, solution part. Now you have coincident lines. Coincident lines are the lines that are coinciding on each other. Okay, so maybe there is something that is connecting that we'll learn in the next part. So what is the meaning of coincident lines is, one line is upon another, superimposed on the other one, such that you cannot make out whether that is the first line or the second line that you are talking about. Okay, that is coincident, incident, intersecting and parallel lines. Before moving on to the exercise, just we need to know the general form. We had already dealt with this. So this was a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. And all of those are real numbers, that is a1, a2, b1, b2 and c1, c2. So there arises one more condition, that is a1 square plus b1 square is not equal to 0 and a2 square plus b2 square is not equal to 0. What is the simple meaning of this? So this looks like a very complicated thing, but it is simple meaning. So when we were dealing with the linear equation in two variables, it was ax plus by plus c is equal to 0, and we told that a, b both not equal to 0. Both not equal to 0. That means that in one case both of them cannot be equal to 0. This same case is just represented in this manner. So here it represents that a1 and b1 both not equal to 0. Both not equal to 0. So how that case has arisen? So let me think in opposite direction, that is a1 square plus b1 square should be equal to 0. If a1 square plus b1 square should be equal to 0, since these two are square numbers, that can come only in the positive. Yeah, it cannot be any negative real number. It is going to be only the positive real numbers. Since it is a square, the smallest square number or the smallest non-negative real number comes to be 0. So since it is a sum and is the square, both of them need to be 0 such that you can satisfy this equation. That's what it shows here. That is a1 square plus b1 square together they cannot be equal to 0. They can be separately 0. Maybe this is 1 and then this is 0. b1 is 0. That's okay. But both of them together cannot be equal to 0. Okay, now we are going to start with exercise 3.1. You have a question here. The question is, Aftab tells his daughter, 7 years ago I was 7 times as old as you were. Also, 3 years from now I shall be 3 times as old as you will be. Okay? You need to take that properly. You need to tell about the present age, 7 years ago, and also the 3 years later. So in such a case, you are going to have two cases because it is given about 7 years ago and about 3 years later. So for that we need to have our present ages, their present ages. That is Aftab. So this is the first question. Let Aftab's present age be x years, and that of his daughter be y years. Okay, it is given 7 years from now, so 7 years before, so it was x minus 7. His age was x minus 7 and her age was y minus 7. It is given that his age was 7 times that of his daughter's age, so it is 7 times this. This is the equation. So the formation of equation is also important when it comes to a statement problem. So the question here has to be about representing it in the form of a graph, and just it is not asked to find, just represent it. Okay, so just by simplifying this, you can bring this 7 this side. This becomes x minus 7y is minus 42 is equal to 0. This is the first equation. Okay, that was the first case where we had found out that was 7 years before. So now we need to speak about what is 3 years later. 3 years later, age of Aftab becomes x plus 3. X plus 3, and her age, that is daughter's age, comes to be y plus 3. Okay, now it is given that age of Aftab becomes 3 times the age of this daughter. So it is going to be like this. So how do you represent this? Just by making it here and there, you can make out that this becomes x minus 3y minus 6 is equal to 0. So this becomes the second equation. Okay, so this much is all about the formation of the given equation of the given statement. The second part of the question you have tells you have to represent this algebraically and also graphically. Graphically, you need to have the graph. For that you need to represent two lines. Okay, so for that I need the tables, where in the previous chapter I have done for polynomials. Similarly, I need to do that for this also, and I'll also have the Cartesian graph. Okay, now we'll have the first line. First line we have x and y. Okay, let me take some general points. So when x is 0, what will be y? This is going to get cancelled. Y is going to be 6. Okay, next one will take x to be 7. When x is 7, what is y going to be? Okay, so how we will try that 7 minus 7y minus 42 is equal to 0. 7 minus 42 is how much? 7 minus 42 is equal to 7. Why? 7 minus 42 is minus 35 divided by 7. So y comes to be at minus 5. This is minus 5. Okay. The one more point I think we need. That point is going to be at, so I'll take minus 7 because it's all about 7, 7 and so many things. All things are about 7. So 7, 7, 7. So this comes to be minus 7. Minus 7 minus 42 is equal to 7y. This is just all about rearranging. Minus 7 minus 7y minus 42 is equal to 0. I am going to take 7y to the right hand side, comes to be 7y. So this is minus 49 is equal to 7y. Okay, so y is minus 7. So this is minus 7. You are going to get these 3 points and just directly draw the graph. I'm not going to draw the graph here. It's very simple. I have also taught in the previous chapter. Now we have the second graph. Second graph, you need 3 points at least. For confirmation, you are asking for 3 points. Otherwise, 2 points are enough to draw the line if you are sure enough. So now you have x minus 3y minus 6. So better I'll take multiples of 3. So first I'll take 0. When x is 0, y comes to be minus 2. Y comes to be minus 2. Here it has to be minus 6, right? Okay, similar it is. Here you get minus, here you get minus 2. So next point, let me take 3, I think. 3. If I take x to be 3, this becomes 3 minus 6 is equal to 3y. 3 minus 6 is minus 3. Minus 3 is equal to 3y. Y is equal to minus 1. Now I'll take minus 3 here. Minus 3. When it is minus 3, more I'm going to get is minus 3 minus 6 is equal to 3y. Y is equal to minus 9 divided by 3, that is equal to minus 3. I'm going to get minus 3 over here. So you got 3 points here also, 3 points here also. No need to worry. Just go on plotting the lines. That's the question. Okay. Okay, now we have the second question. Second question is about this exercise 3.1 has come here. Okay, it is the coach of a cricket team buys 3 bats and 6 balls for 3,900 rupees, and later she buys another bat and 3 more balls of the same kind for rupees 1,300. You need to represent the situation algebraically and geometrically. Algebraical representation is direct finding the equation. Geometrical graphical representation, you need to show it on the Cartesian plane. Okay, for that first you need to consider, let the cost of a bat be rupees x. Okay, we'll take the new one, that is rupees x. Okay, and that of a ball be rupees y. You have x and y, you are already told. So what is the condition given here is, the first case they have bought 3 bats and 6 balls. 3 bats and 6 balls cost rupees 3,900. It is given in such a way. Okay, so from here you can see that 3 is common, so I can make it into a simpler form. This becomes x plus 2y is equal to 1,300, or x plus 2y minus 1,300 becomes 0. Okay, this is the first equation. Now the second time when she buys the bats and the ball, she buys 1 bat and 3 balls. 1 bat and 3 balls. It cost her rupees 1,300. So I can write it as minus 1,300 is equal to 0. This becomes the second equation. Okay, this is how you form the equation. So you have now x and y for the first case. So it is going to be very similar. Okay, let it be 3 is enough. 3 points. So now we have the first case where you have x and 2y. So let me take x to be 0. When you plot it, it's very easy if you are taking for the x-axis and the y-axis. That means one case when x is equal to 0, that comes in the y-axis, and when y is equal to 0, when it comes in the x-axis. Okay, we'll take both of them here. That will be better. So, generally while taking the graph, you need to take care that it should be better for taking a proper thing. So, if I take this to be 0, I'll get y to be equal to 1300 divided by 2. That is going to land up at 650. 650. So this is coming to be 650 in this case. In the second case, y I substitute it to 0, so x directly becomes 1300. Okay. Now you have, I'll put some 100 here. I'll put 100. What does this become? This becomes 100 minus 1300 is equal to minus 2y, or 2y is equal to 1200. Y is equal to 600. 600 comes up here. So you are going to get 3 columns. So 3 points. It's easy to draw the graph. If you find any error in while checking, you need to just check these points once more over there. Okay, the second line is x and y. 3 more points. 3 more points you need to find out. For that you have x and 3y here. Here you need to take care while putting x is equal to 0. You are going to get 1300 divided by 3. But it is very difficult to locate a point which is 1300 by 3. So I opt not to put x is equal to 0 in this case for my convenience of drawing the graph. So now y is equal to 0, let me consider. This becomes x is equal to 1300. X is equal to 1300. Okay, now we have one more point. For that one more point, let me consider x to be 100. X to be 100. When x is 100, let me substitute and see. 100 minus 1300 is equal to minus 3y. I'm taking this 3y term that side, it becomes minus 3y. Substituting 100, this comes to be minus 1200 divided by minus 3. I'm bringing to the denominator. Minus and minus get cancelled. You get y is equal to 400. 400 is the point you're going to get here. Okay, similarly, I'll take one more number. I'll take this to be 400. What is 400 going to be? When it is 400, so I'll substitute 400. So it is 400 minus 1300 is equal to minus 3y, or y is equal to 4 minus 13 comes to be 9. So this is minus 900 divided by 3, that is equal to 3 minus, so this comes to be 300. So you got these 3 points. You can take 100 as a scale here rather than going by 1300 divided by 3. So why I have chosen 400? Because when you take 400, this number, that is minus 900, is going to be divisible by 3, and you are going to get a whole number that is in hundreds. Otherwise, if you take 200, you are going to get some number that is not divisible by 3. So you are going to land up as a first case when I had to take x to be equal to 0. So that is a better option. Okay, now we have the third question. You have the third question here. Now it is telling that the cost of 3 kg of apples and 2 kg of apples and 1 kg of grapes on a day was found to be rupees 160. Okay, on the same day. So what was that? It is given in the same month. Okay, whatever it is the same. The cost of 4 kg of apples and 2 kg of grapes was found to be 300. You need to represent that algebraically and geometrically. If you are asked like that, so first of all, as in the previous one, you need to tell what it is. Let the cost of each apple be rupees x. It should be rupees x. And that of each grapes. How can they count the grapes and give? Okay, whatever it is, they're giving cost of each grapes. maybe a bunch or something, be rupees y. Okay, what is the first case telling is 2x plus y is equal to 160. Or I can tell that it is 2 kg of apples, not each kg, right? Each kg of apple and each kg of grapes. Okay, they are giving kg, right? So 2x plus y is equal to 160 is the first one. Second one is it is given 4 kgs of apples and 2 that of grapes is to be 300. This was the direct one, so maybe I can cancel this off instead of writing all these things because there is 2 common out of this. So I'll take 2 out of this, cancel 2 everywhere. This becomes 2x plus y is equal to 150. What we are going to get in this? Okay, you have the first line and the second line. You have x and y. You have x and y in both the cases. Okay, first we'll take 0 as in always done. We'll taking 0. When x is 0, y is 160. When y is 0, x is 80. Okay, now we'll put some other number, maybe any number I can put here. I'll put 40 here. 40 is a number in between these two, 0 and 80. So I'm putting 40, this becomes 80. So this is 80 here. Because 2 into 40 is 80. You have 160 here. So 80 you are going to the right hand side, it becomes 80. So y is equal to 80. So now we have the other one. 2x plus y is equal to 150. I'll take the value of x to be 0. When x is 0, y is 150 itself. When y is 0, x is 75. That many points I got. So now I need to take the number better in between 0 and 50. So I'll take this y to be some other number. So maybe something that should be divisible by y. So I'll take it to be 30 here. It will be 30 or 50. I'll take 30, it's okay. 30. So 2x plus 30 is equal to 150. 2x is equal to 150 minus 30, that is 120. X is equal to 60. So you're getting 60 here. 60, 30. So this many points, just plot that. So just by, okay, not just by, it is understood that there are going to be 2 parallel lines in this case. They need to be perfectly parallel. I will explain why it is in the next session, where it is about the graphical method of solving a pair of linear equations. Here we are just representing it in the form of graph. In the second part we are going to have it by how we are going to graphically solve by forming it on the graph. We are going to draw lines and find the point of intersection of these things and find the solution of the pair of linear equations in 2 variables. Okay.